I want to talk about how advances in GPUs, graphics cards, and cloud computing has enabled capabilities for people like you and me that used to only be available to hacking groups. So both these capabilities you can get a hold of for $100. If you have a credit card, you can do this at home. The first is, we've heard a lot about this, it's a denial of service attack, very much in vogue. The next one is reverse hashing, which is cracking protected passwords. So a quick picture about what a denial of service attack looks like. Essentially, we get a bunch of computers to work together. They're centrally orchestrated, and we send a ton of malicious traffic at some particular mail or web server that we want to take down. What does that kind of feel like, from the inside? Well, I don't know if you've ever shopped on a Black Friday. That is exactly what a denial of service attack feels like. There's so much traffic trying to squeeze through, like little turnstiles, parking, point of sale systems, everything kind of grinds to a halt. It's just completely miserable. So it used to be the case that if you wanted to deliver a denial of service attack, you'd have to first build a botnet. You'd have to either author your own malware, go find some from the internet, infect a ton of computers and distribute this stuff, and then finally start orchestrating these machines so you can get this job done. You don't really have to do that anymore. There is so much more computing power available to every individual here who owns a credit card. For a little over half a penny an hour, anyone can put a machine in the cloud. And what you do with these resources is kind of up to you. I want to compare that with computing labor has gotten a lot cheaper. Human labor has gotten quite a bit more expensive. So not picking on Starbucks here, but their wages are in the media right now. And so for about $30 an hour, you can hire 2 baristas. I want to contrast that with that same $30 an hour. You could spin up 5,000 computers to do your bidding. And imagine what you could do with that. This was not available a while ago. You don't have to go do a denial of service attack. That's illegal. But you could use that same computing power to solve all sorts of... If you like building things, you can use that to model what the weather's going to look like 50 years from now. How are these theoretical cancer treatments going to behave? Or you could help people find aliens. There's so much that you could do with this. That's capability 1. Capability 2 is... passwords. We kind of touched on this a little bit tonight. Passwords aren't safe anymore. Over on the right-hand side of the screen, that's what your password looks like when it's stored on some identity system. So it used to be the case that, and the reason why we hash these things, a quick note about hashing functions. So we take your password. We don't want to store this in clear text on disk. So we take your password, we put it through a hashing function, and your password in the bottom right over there, we see dog. That gobbledygook, that string, is the hashed version of that password. And so that's what we actually store. When it comes time to log in, this is what your login experience is like. A user shows up to some login page. They provide a username and a password. We hash the provided password. And that's what we compare ultimately to what's stored on disk. So nothing in clear text is ever stored. This is super important because data goes missing all the time. I want to fast forward to that 5th bullet, LinkedIn. Pretty much everyone here is on LinkedIn. Everyone in this room's data was stolen in 2012. That totally happened. And that'd be fine, right? I mean, we hash these passwords. We've got nothing to worry about. None of this is stored in clear text. Well, most of it's not stored in clear text. But GPUs have gotten so much faster these days. So, and what used to be really fine passwords, like perfectly acceptable passwords, aren't secure anymore. CPUs, real quick comparison, have a couple cores. They're optimized mostly for serial operations. But GPUs, on the other hand, have thousands of cores on a single GPU and are optimized for incredible throughput. Hackers are using this throughput to crack what used to be a very safe password. We could coin a new one tonight using most secure guidance. We could crack it in 34 minutes, worst case scenario. A good attacker would likely break it in under a minute. So you don't have to access this. You don't have to build what's over here on the left. I mean, that looks like a fire hazard, and your spouse may not let you get away with it. You could also rent these same capabilities in the cloud, and you don't have to use that for cracking passwords. I mean, you could, but you could also use that for, we talked about deep learning tonight. GPUs can train neural nets, especially deep learning neural nets, about 170 times faster than you could with a CPU. And there's never been more libraries or frameworks to help you get this job done. All right, so wrapping up, for under $100, a lot less than $100. You can provision your own botnet or distributed computing cluster. You can crack about 90% of the passwords that are in the world these days to go download a torrent and have some fun. You could train a computer how to find human beings or water on Mars. There's so much that you can do these days. I'm Tyler Holmes. Thanks for the time.